This is the fourth question in IGCSE Past Year Paper Addition and Mathematics 0606 2 October November 2018 series. Solve 2 to the power of 3x minus 1, which is equals to 6. And this is a 3 marks question. And obviously it involves indices, but in this case, all you have to do is to use ln, or you can use log as well. It doesn't matter. Let me write it down. It's either using ln or you can use log. So it's a mix of indices and logarithm knowledge over here. So all you have to do is 2 log 3x minus 1 equals to log 6. And then same, you shift the 3x minus 1 down from the top, and it gives you an equation like this, which are pretty similar. It doesn't matter, either way works fine. And here you just have to shift your ln 2 to the bottom of ln 6. So these are the part that doesn't involve x. So you move them to your right hand side first, right hand side of the equation first. Then you plus your 1, which you shift it from the left hand side to the right hand side. So you have to change the sign, become from minus to plus over here. And all you have to do is to press your calculator. Ln 6 over ln 2 plus 1, you will get 3.5849, a long line, like it goes forever, but it's best to write down whatever is shown in your calculator. So when you simplify your answer, the examiner know where you get your answer from, or you simplify it from the calculator, the figures that are shown in your calculator. So it's best and easier, it's best to do it this way to secure your marks, rather than writing the last line here down immediately from here to here. And after that, you can move on to your second part. So log with the base of 3 bracket y plus 14, and it's equals to 1 plus 2 over log with the base of y and 3. And it's a 5 mark question here. But do not worry, all you have to do is to first change the base to become the same base over here. So since we have a 1 over here, we have to change it first. So in order to change 1 into something with similar base, here I chose to change the entire equation to have the same base of 3 here. So since here already have a base of 3, I keep it the same on the left hand side. However, here the 1 over here, I change it to log 3 with the base of 3. Since I know this is equals to 1, I just write it in another form. And here I remain the same for now. And after that, I start to manipulate this part. In order to change the base y to become another base, I turn it around. So all you have to do, this is the law of logarithm. If you want to change the base, you have to invert it. So in another word, as you change it, you change from the bottom to the top. It changes from 1 over log y3 to log 3y. This is the way you convert these two usually, and it's really very useful to remember. It helps you with your other calculation with related with similar questions in the past year as well. Since I know this is basically equals to this, all I have to do is to sub in 2 log with the base of 3y to the parts over here. So then all of them will have the same base of 3. Then I know that I can just eliminate the log 3 from now on. But when I eliminate the log 3, especially for the parts on right hand side here, you need to be careful that log 3 plus 2 log 3y is not equals to log 3 plus y is equals to log 3 multiplied by y squared. Since the 2 here, you are supposed to move it up to the right corner up there above y, and then here, well, here still remains the same. There's nothing much to do over here. Then you can proceed or eliminate the log 3 outside of the bracket here. Then you will get a quadratic equation. When you get quadratic equation, of course, you're supposed to simplify, factorize the equation in this way. If you need help on simplifying the equation, let me know. I will make another video guiding you how to simplify and factorize your equation over here. And if you have questions or doubts about the laws of logarithm and how to manipulate it in different cases, leave a comment at the bottom. I will make another video explaining indices and logarithm manipulation as well. But in this case, we will just factorize this equation first, where you will get 2 different answers for your y. However, you have to eliminate the answer with a negative 2, because the y cannot be negative over here, since above here the y itself is the base of a log, and the base of the log can never be negative. You need to be careful. Hence, you're supposed to let the examiner know that you reject this answer, and this will be the only answer in order to get all your 5 marks. So to get all your 5 marks, this is definitely 1 marks out of 5, and over here to reach this quadratic equation is another mark as well. The manipulation of this part of the first part here, where you change the 1 to log 3 will also get you 1, or give you 1 mark, and then the part over here will also give you 1 mark. There's knowledge of logarithm manipulation, and then the process over here will be another mark as well. Moving on to the 5th question, or question 5, solve the simultaneous equation. So these 2 are the equations that you have to solve. You have to find, obviously, the values of p and q, and that's all you have to do. But it's a 5-mark questions, and this involves all these indices, which means that it requires more than a few steps. So first of all, you change one of the equation into this form, change them all into the power of 2, because you notice all of them can be written in power of 2. So all you have to do is to change a equals to 2 to the power of 3 multiplied by what was shown on here. Just have to copy them down, but put them in the bracket. Remember to put them in the bracket. And here you change it to 2 to the power of 2 multiplied by q. The q here you mustn't forget. And all you have to do is to remember that the law of indices is simply that when this is the case, all you have to find is the divide here. If in the case for the power, it becomes minus. So it becomes 3p plus 3 minus 2q, where we can omit the 2 over here already. And then I may as well write down the law of indices again, where any value x, the power of b over power of a, is actually equals to x, the power of b minus a. Do you remember this? And since this part is actually equals to 2 to the power of 3p plus 1, bracket, remember the bracket, minus 2q, and that's equals to 2 to the power of 11. Hence, we can just omit the 2 over here, and that's how we got to this stage. And after that, you can shift the 3 to the left-hand side, where you only get 8 on your right-hand side. Sorry, left-hand side to right-hand side. And you keep your unknown the same on your left-hand side. And the same we'll do the same thing for the second equation here. Here we notice that 3, 27, and 9, they are all the power of 3. So all you have to do is to change 27 to 3 to the power of 3 multiplied by what was already on here, on top over here. And over here as well, you have to change the 9 to 3 to the power of 2 multiplied by 3q. And all you have to do is to again write them all down. where the process is the same based on this law of indices, you can actually change it to the form of 3 to the power of 2p plus 5 minus 3 multiplied by 1 over 3, and that's just directly equals to 3 to the power of 2 multiplied by 3q. Hence you can just ignore the 3 when you solve your p and q over here, and then you shift your 1 to your when here you can actually just write for if you're okay. So as you shift the positive 4 from the left hand side to the right hand side, becomes negative 4. And after that, you may label these two equations as equation 1 and equation 2. And then, because when you eliminate one of the unknown over here, you have to change one of them into the same term. So in this case, I multiply equation 1 by 3 because I want to change the unknown q over here into the same. So here, when I multiply by 3, it becomes negative 6. And 3p over here, since I multiplied the entire equation by 3, becomes 9p. And then 8 multiplied by 3 becomes 24. And this is our third equation that we're using. In another word, I modify equation 1 into equation 3, so it's easier to solve my remaining solve the remaining question and solve this remaining question. And when I plus 2 and 3 together, which means that positive q plus negative q, it will actually just eliminate the q. So all we have left is 9p minus 2p. That's equals to 28, because I plus the two equations together. Remember, I did not minus them, I plus them because one of the value here is positive and another is negative. If both of them are positive or both of them are negative, I will minus them. But this is the basics of solving simultaneous equations. So all you have to do is to sub your p into your equation to get your value of q here. And that's how you approach this question. This is one of the most straightforward ways, I would say.